In this video, I'm going to give you some important tricks to solve some difficult problems of superposition principle in electrostatics. Suppose if you have given more than two charges and you want to find the force acting on one point charge, the situation becomes difficult when the charges are not in xy but also in x, y and z plane. So first, let me write what are the important tricks I'm using in this. First, place the charge. Place the charge at origin on which you wish to find force. Second important trick is write coordinates of each charge. Third, if the force is attractive, use positive sign. If the force is repulsive, use negative sign. Okay, so these are the three important tricks. Place the charge at the origin on which you wish to find force on it. Second, write coordinates of each charges. Then third is, if force is attractive, then use positive sign. If the force is repulsive, use negative sign. Let me explain this in this example. Suppose you have given 4-point charges which are at the corners of an equilateral triangle, so corner of a square of side 1 meter. Say there's -1 microcoulomb charge, there is 2 microcoulomb charge, say this is -3 microcoulomb charge, say this is 4 microcoulomb charge, and we wish to find the force acting on -1 microcoulomb charge. So here the question is, find force on -1 microcoulomb charge. So how we'll write? See, we can write in just one line. Say the net force acting on -1 microcoulomb charge. Say this is origin. Call it this is your x-axis. Call it this is your y-axis. Now you can write the coordinates of each charge. This is what 1, 0. This is going to be 1, 1. And this is going to be 0, 1. So the net force would be the proportionality constant that comes out to be straight away 9 into 10 to the power 9. I also multiplied with the micro, that's a 10 to the power minus 12 into. Now the force between -1 microcoulomb charge and 2 microcoulomb charge, it would be, since -1 and 2, the force will be attractive. That's why I'm using plus sign. It's a 1 into 2 upon the distance square. A line joining from 0, 0 to 1, 0, the vector would be, it's a 1 I cap plus 0 j cap. So 1 I cap plus 0 j cap. So what will be its magnitude? Its magnitude would be only 1. So here it comes out 1 square. Now we want to write the direction. And how we write the direction? It's a r cap. That would be the vector upon its magnitude, which is only comes out to be I cap. It's a I cap. So in a straight way, we can write the force between -1 and 2 microcoulomb charge. The same way, we can also write the force between -1 and -3 microcoulomb charge. -1 and -3 microcoulomb charge. See, his coordinate is 1, 1. So a line joining from the vector point origin to the point 1, 1 would be, it's a 1 I cap plus 1 j cap. Its magnitude would be, it's a root 2. and its unit vector would be the vector upon magnitude, that's I cap plus j cap upon root 2. And the force between -1 and -3, it would be repulsive. So straight away we'll write minus sign. 1 into 3 upon the distance square, that's a root 2 square. The unit vector which comes out to be I plus j upon root 2. That's it. Now, the force between -1 microcoulomb charge and 4 microcoulomb charge, it would be attractive. And in the same way, we can write its plus sign 1 into 4 upon 1 square into j cap. Now what you have to do is simplify some constant times. It comes out to be I cap, some constant times it would be j cap. If you want the magnitude, you can easily write the magnitude will be under root of coefficient of I cap square plus coefficient of j cap square. That much Newton will be the answer. Now let's discuss some difficult problem based on this tricks. Suppose you have given again more than two charges, but not in only xy plane, but it's a xyz plane. Okay. For example, say there's a rectangle of size 2 meter by 1 meter. There is a point charge of 2 microcoulomb. Okay, there is a charge of 3 microcoulomb. This is -4 microcoulomb. This is 5 microcoulomb, and there's one more fifth charge which is perpendicularly away from the center of the rectangle. There is that fifth charge is of the value 10 microcoulomb charge, which is perpendicularly away at a distance of 1 meter. Okay, so this 10 microcoulomb charge is perpendicularly away from the center of the rectangle. Now, first, say if the question says find the force acting on 2 microcoulomb charge. Force on 2 microcoulomb charge. Okay, the force on 2 microcoulomb charge. So by the given trick, write the 2 microcoulomb charge, that's at origin. Write down the coordinates of each charge. It's a 0 0 0. 3 microcoulomb charge. 3 microcoulomb charge would be it's a 2 0 0. Okay, and -4 microcoulomb charge, the coordinate would be it's a 2 1 0. The coordinates of the 5 microcoulomb charge would be it's a 0 1 0. And the interesting thing is coordinates of the 10 microcoulomb charge. Okay, you can see I have taken this as a what x-axis, this as I've taken as a y-axis, and I'm taking out of the board as a z-axis. So the coordinate of 10 microcoulomb charge would be, yes, this is 1 x coordinate, then this is y coordinate, it would be half, and perpendicularly that's a z coordinate, and that would be 1. Now again, if the force is attractive, we'll take positive sign. So we have to write force on 2 microcoulomb charge. See, I'm writing just in a one stroke. Otherwise, this problem will be very difficult if you resolve all the forces. We can write, but here by this method, you can write in a one stroke. The force acting on 2 microcoulomb charge. Again, it's a coefficient value 9 into 10 to the power 9. That's a value of 1 upon 4 pi epsilon naught. Micro and micro, that again comes out to 10 power minus 12. Now, force between 2 and 3, because both are positive, the force will be what? It's a repulsive. So that's why I'm using negative sign. It's a -2 into 3 upon the distance square. A vector joining line from origin to point 2 0 0. That vector would be 2 I cap that vector would be, it's a 2 I cap, so its mod will be only 2, so this is 2 square. What will be its unit vector? This will be the vector upon its magnitude, which would be only I cap. It's a I cap. Now the same way I'm writing the force between 2 microcoulomb charge and minus 4 microcoulomb charge. 2 microcoulomb charge and minus 4 microcoulomb charge, that force will be positive. This coordinate is 210, okay? So you can write its vector to be this vector as a 2I cap plus j cap, which magnitude would be, it's a root 5. So what will be the answer then? It's a 2 into 4. I use positive sign because the force is attractive, upon the magnitude, which is root 5 whole square. And what would be the unit vector? The unit vector would be, it's a vector upon its magnitude, which is 2I cap plus j cap upon root 5. The same way, we can write the force between 2 microcoulomb charge and 5 microcoulomb charge, because both are positive. The force would be what? It's a repulsive. So that is why we use the negative sign, minus. It's a 2 into 5 upon the distance square, 1 square, and the unit vector would be j cap. Now, the most difficult one comes is the force between 2 microcoulomb charge and the 10 microcoulomb charge. Now you can see the 10 microcoulomb charge, this is not in xy plane, but it's in xyz plane. That force, it's not easy to resolve that force in x, y, and z coordinates. So what I do is, we have to find the force acting on 2 microcoulomb charge. This is 10 and 2, both are positive. The force would be what? It's a repulsive force hoga. And then write the vector, a line joining from origin to point 1 half 1, it would be I cap plus j by 2 plus k cap, which mod would be, it's under root of 1 plus 1 by 4 plus 1, it's a 2 plus 1 by 4, it's a 8, 9 by 2, that's a 3 by 2. Okay, and so just writing this, the force between 2 and 10 microcoulomb, the force is repulsive, that's why negative sign. It's a 2 into 10 upon the distance square, 3 by 2, that vector modulus, 3 by 2 square, okay? And now I'm writing the unit vector. The unit vector for this would be, it's a I cap plus j by 2 cap plus k cap upon 3 by 2. See, now question solved. The rest thing what you have to do is, you have to write coefficient of I cap plus coefficient of j cap and coefficient of k cap. If you want the magnitude of this, you can write its magnitude would comes out to be under root of coefficient of I cap square plus j cap square plus k cap square. Okay, by this way you can find the force acting on charges. Okay, in the next issue we'll discuss the force acting on 10 microcoulomb charge. Okay, we'll do the same thing. Place the 10 microcoulomb charge at the origin and then try to write coordinates of all these 4 charges. Okay, and if the force comes out to be attractive, use positive sign. If the force is repulsive, use negative sign. This question will explain in my next issue. Please don't forget to like my video and subscribe my video. Thank you.